Working on section 5-2, multiplying and dividing rational expressions. So just like fractions are typically easier to multiply and divide, I also think that rational expressions are easier to multiply and divide than add and subtract. A lot of this in rational expressions, you need to deal with factoring. So we've already done a factoring review in class. I expect at this point that factoring you can knock out pretty easily, and it will make this whole section much easier for you. So let's just do some quick basic fraction reducing here. So 20 over 24, that's a fraction that each of those can be divided by 4. So you reduce that to 5 over 6. 4x over 7x, the x can be canceled out in both those cases, so you get 4 over 7. Once you have an expression in factored form, you can cancel out any factor that occurs on the top and the bottom, because x plus 3 divided by x plus 3 is the equivalent of 1. So that can be factored out. And you would just get 4 over x minus 3. Remember that that is one piece. So if this number, say that happened to be a 4, you would not be able to cancel out the 4 with the 4, because 4 would have to be a factor that you could cancel out of the entire denominator, and 4 can't be canceled out of x. That's a really common mistake that I want you to be really aware of, not to make. Okay, AC over BC, well, C is common to both, so that would just be A over B. And in this case, so here's a perfect example. So some will look at that and say, oh, well, I've got a 4x and a 2x, so I can just cancel the 2 out into the 4. What you need to think about what you're doing. Here, I could take a 4 out of each of those. Okay, I have to be able to factor something out of both expressions. There's no number that factors out of 4 and 3, so this can't be simplified any more than it is. Same goes for 2x minus 9. There's no number that can be factored out of 2 and negative 9. So this is in fact simplified. You cannot simplify it any farther than that. Okay, and we'll talk more about that. So when you're simplifying, an excluded value is any value, think about those vertical asymptotes, any value which occurs in both the numerator and the denominator. So let's think about this third example up here. If I went to go graph that, okay, we would have 4x plus 3 and x minus 4x plus 3. And so I would look at that denominator and go, okay, I've got vertical asymptotes at 4 and negative 3. The problem is that 3 cancels out. So this negative 3 is an excluded value. Okay, so let's practice with some here. So x plus 4 over x squared minus 16. We did a lot of practice with our product of a sum and a difference in class. So these, when you see these now, I want you to be really good at them. That's a perfect square. That's a perfect square. Take the square root of the front, which is x, square root of the first term, square root of the back term, which is 4. One is a sum, one is a difference. So now the x plus 4 and the x plus 4 can be simplified. So you get 1 over x minus 4. Our excluded value is going to be at x plus 4 or at x equals negative 4. It's whatever makes that 0. Okay? So let's find out what we can, anything that's not factored with when you're dealing with rational expressions, first rule is to factor everything. Makes everything much simpler. You can't really see what cancels out until you get your factors in front of you. So that's going to be the first thing that we need to do. I can take a 2 out of 2 of 12, and I can take a p out of p squared and p. So I'm going to factor out 2p, and I'm left with p minus 6. On the bottom, I need two numbers that multiply to negative 24 that have a sum of negative 2. That's going to give me p minus 6 and p plus 4. My p minus 6 can cancel on the top and the bottom, which also becomes my excluded value. And my resulting answer is 2p over p plus 4. remember, that 2 and that 4 cannot cancel. I would have to be able to take a 2 out of every term, and I can't take it out of here, just like I can't take a 2 out of every term. Every term must be included. Okay. All right, so let's go and multiplying. And multiplying is nice because we can multiply anything on the top with anything on the, we multiply everything on the top, multiply everything on the bottom. Anything that can cancel on the top and bottom, I would do first. It's always easier to cancel and then multiply, whether you're dealing with simple fractions with no variables or whether you're dealing with rational expressions. So let's do first things first. So 2 can go into 4 twice. 3 can go into 9 3 times. So as far as coefficients, now all I have is 2 times 3. That gives me a 6. So there's a couple ways that you can do this. I've got 2 x's on the top and 1, 2, 3 on the bottom. So I can cancel out that x times x is x squared. That can cancel out with the x squared on the bottom. So all I'm left with is an x on the bottom. I have 1 y on the bottom and 3 on the top, which means one of those y's cancels out, which leaves me with 2 on the top. So it simplifies down to there. When you're dealing with more complicated rational expressions, I would factor these first, because if there's something that will cancel out, it will make all of your multiplication more condensed and much, much easier. So one by one, let's go ahead and factor these. So 3 can go into both 3 and 9. So my factorization is 3 times x plus 3. And as I factor things, I tend to cross things out, just so I know that I dealt with it. I don't accidentally do it a second time. And it's a little bit more organized that way. If I factor out x squared plus 7x plus 12, the two numbers that add to 12 that multiply to 12 that add to 7 would be x plus 3 and x plus 4. Can't cross that out. And then here we go with perfect squares again. So I'm going to get x plus 5 and x minus 5. Now everything is a lot easier to cancel because now I've got an x plus 5 on the top and x plus 5 on the bottom. Those go away. I have an x plus 3 on the bottom and the top, so that can go away. So the only thing that I've got left is 3 in the numerator, and then x plus 4 and x minus 5 in the denominator. My advice is to leave everything in factored form. You can always multiply these back out. I think it's more helpful and more concise to just leave it in factored form. There's nothing wrong with that. Okay, let's go down here. So down here again, I'm going to factor that so I can take a 2 and an n out of both. And then remember, this is like 2n squared minus 5n minus 3 over 1. This 2n squared minus 5n minus 3, that's where we're going to need to use x factor or BFDs to factor that, because I've got a number larger than 1 as my leading coefficient. So I'll go ahead and do both. BFDs, I'm going to bring that across, get n squared minus 5n minus 6. So the factors of that are n minus 6 and n plus 1. I need to divide out that a value. So my factors are n minus 3 and 2n plus 1. Because if this reduces down, if this does not reduce down to a whole number, we just swing that denominator out in the front. Okay. I'll go ahead and do x factor also, just as a refresher. Your a value and your variable go on top. Your AC value goes here. Your b value goes down here. Then you factor and reduce. This reduces to 1 and 3. So you get n minus 3 and 2n plus 1. Either way, you need to be good at one of those ways. Okay. Now I've got that down. Now I can start canceling. So all I have, these do not cancel because they're both in the numerator. So I've got n minus 3. You can either write it n minus 3 times n minus 3 or just n minus 3 squared would be fine, over 2n. Okay. What do we know about division of fractions? We know that that is the same as dividing. When you divide by a fraction, it's the same as multiplying by a reciprocal. So what I actually do is I just flip them right here and now and cross out that second fraction. It's kind of how I do them. I think it's easier than rewriting the entire problem. And now I can kind of go cancel. So my x's cancel out on the top and bottom. Remember, they only cancel with one of them. They wouldn't cancel with this also. And 3 goes into 6 twice. 5 goes into 15 3 times. That x squared can't cancel with anything. So in my numerator, all I have left is a 3. In my denominator, I have x squared and 2. So that reduces to that. Now, you can, if you feel the need to, you can always multiply the top together and then divide. So here I would have 3 times 6 is 18 and x squared. And on the bottom I would have 5 times 75 with, 5 times 15, which is 75 x squared. So you can definitely do that. Oh, excuse me, I didn't flip mine over, did I? Okay, when I flip it over, I have 3x times 15, which would give me 45x. Sorry about that. I was looking at the original problem. And on the bottom, I would have 5 times 6, which is 30, and x cubed. So we can still do that. 15 goes into 45 and 30, goes in here 3 times, goes in here twice. X cancels out, so I would have squared in the bottom. So I would still get 3 over 2x squared. So it's certainly your preference as to how you do it. My advice would be to cancel first, because if we get numbers a lot larger than this, that simplifying in this step is going to become a lot more complicated. Okay, so let's flip this around, and I'm going to go ahead and factor this right now, because then when I flip it, it's already done. And now I don't need any of this anymore. Now here's another little wrinkle that's going on with this one. So here I've got an m minus 2. This I've got 2 minus m, which is close, but not close enough. So the problem is that both of my signs are the opposite of what I need them to be. So I want you to think about what we can do to make our signs become the opposite of what they currently are. And that is by multiplying by -1 or dividing by -1. So I can actually change this to -1 times m minus 2. And if I double check that, -1 times m is -m. -1 times -2 is 2. So you're just changing the signs and then taking that -1 out of both. That will allow us to cancel those m minus 2's. If we didn't do that, this is not the same factor. The signs are opposite, and so it's not the same. So you'll see that fairly often in rational expressions, and all you have to do is just take that -1 out, and then you're good to go. So now we can cancel. So our m plus 5's cancel. Now that m minus 2 is going to cancel. So on the top, all we have is m plus 2. And on the bottom, all we have is 3 and -1. So we just multiply those together and get -3. Okay, so let's do another one for practice. So this first fraction is as simple as it can get, just y minus 4 over y plus 5. This one is not, but I'm going to go ahead and flip that over. So this would be the same as y squared plus 5y minus 36 over 1. So I'm going to switch that, and I'm going to factor this. So the two numbers that would multiply to -36 that adds to 5 would be y plus 9 and y minus 4. So now I can get rid of all of this, and now this is already factored. So my y minus 4 cancels. I have nothing left on top but a 1. And then on the bottom, all I've got is y plus 5 and y plus 9. Not so bad. Okay, so I want you to see something pretty, this is going to kind of blow your mind. So a lot of times when you see a fraction divided by a fraction, you think, Miss V, what are you trying to do to me? That just gives me a headache. I don't want to do it. But I figured out a really neat trick to make that a lot easier. So think about when we're doing fraction busters, what we would do. If I gave you 1/3 plus 1/4, you would find a number that they both go into and multiply both of those fractions by that. So in this case, that would be 3 times 4 is 12. I would multiply each of those by 12, and I would get 4 plus 3, and boom, so much easier, not a problem. You can apply that same practice to this right here. So what I want you to do is look at your denominators and find a common factor of your denominators. Trust me on this a minute, okay? So 3 times 4 is 12. So I'm going to multiply this fraction by 12 over 12, which is just 1. I'm not changing the value of anything. I'm just multiplying it. So 12 times 1/3 would be 4. 3 goes into 12, 3 goes into 12 4 times 4. 4 times 1 is 4. 4 goes into 12 3 times 3 is 9. And boom, you're done. Which to me is so much easier than having to rewrite this. You certainly could do this, and you would get the same answer. But I really like eliminating that. I really like that it works with rational expressions quite well. So let's do the same thing here. So 4 and 5, the number that they can both go into is 20. So I'm going to multiply 20 over 20. So 4 goes into 20 5 times. So on the top, I get 5x. 5 goes into 20 4 times 2x would be 8x. Now I've just got to cancel my x's out because they occur in the numerator and the denominator, and my answer is 5 over 8. So much better, so much easier. So now let's do the same thing here. So number that my denominators go into is 9. So I'm going to multiply this entire thing by 9 and this entire expression by 9. So let's do the bottom one first because that seems pretty easy. So we have 9 and 9 just cancel out. So my denominator is just x squared minus 4, which I can also go ahead and factor into x plus 2 and x minus 2. 3 goes into 9 3 times x plus 2. And I'm not going to go ahead and do the distributive property because that doesn't help me. It helps me to have it in factored form because I can see that my x plus 2's are going to cancel. So I'm just going to cancel those out, and now I just have 3 over x minus 2. Okay, even here, pretty easy to find our common denominator because it's the same numerator, or excuse me, it's the same denominator, which is 4x. So I'm just going to multiply by 4x over 4x. Those are all going to cancel, and I just get 3 over 5. If you haven't tried that way for complex fractions, because you probably haven't, and then when you see complex fractions, you think, yeah, they're really complex, Miss V, why are you making me do this? But they happen. We have to know how to deal with them. That's certainly an easier way to deal with them. Okay, so let's go ahead and practice some now. And okay, so let's go down here, and we can factor out a 2 from our denominator. So we get x squared minus 25. That I can go ahead and factor 2 into 2x plus 5 and x minus 5. So I'm going to cancel these out. This is as simple as I can get this now. And so now my x plus 5 factor will cancel out, and I end up with x over 2 times x minus 5. Remember that that x and that x do not cancel. Please do not make that mistake. Okay, and let's go here. We're still multiplying. So let's factor everything first. That'll certainly be easier. So x minus 7 is just its own factor. The two factors that multiply to 30 that add up to negative 13 would be x minus 10 and x minus 3. So now I can cross that out. Here I've got an x cubed going on, but that's okay because I can take an x out of both terms. And then I end up with x squared minus 9 inside. That in and of itself can be factored out. So I get x plus 3, x minus 3. And now I can go ahead and start canceling. So the x minus 3's cancel. I've got an x in the numerator and the denominator here, so that can go away. And I tend to kind of circle things that I've got left over because it makes finding my final answer a little bit easier. So in my numerator, I have x times x plus 3, and in my denominator, I have x minus 10. You certainly can multiply these back if you'd like to. You're making extra work for yourself. I'm not requiring it, so you can just leave it in factored form. Okay. Oh, let's go back here. I forgot about my excluded values. My excluded value would be where x plus 5 equals 0. So that would be at x equals negative 5. Sorry about that. That comes in when we're dealing with graphing. So, okay, and lastly, let's practice our dividing. So I'm going to flip this fraction over to 20y over 5 first. And then 4 goes into 20 5 times. 5 and 5 will cancel. I have 1y on the top and 2 on the bottom. So I can take one of those y's away. So I just end up with 3 over y. Okay, lastly, so 4x and 8. So I know that 8 is a number that 4 and 8 can both go into, but I also need to include that x. So I'm going to multiply this by 8x over 8x. So 4 goes into 8 twice, and the x's cancel. So on the top, I get 2 times 3x plus 9. And in my denominator, 8 goes into 8x, the 8's cancel. I would have x times x plus 3. Now, let's see what else I can cancel here, because that looks like a term that something could be factored out. So I can take a 3 out of both and get x plus 3. So now what I've got left, the x plus 3's cancel. Now I just need to multiply my 2 by 3, which is 6, and I have an x on the bottom. That's it. Multiplying and dividing. Thanks.